Alright, let's begin. Quiet down. Try not to talk, please. Yeah, Jonathan. I am recording, and it makes it harder when I don't have a microphone and you're still talking as well. So like I said, we have that option. The mic can roll now. Don't want to be here, get out. And that's recorded as well. Alright, here we go. Melshi. Yeah. Mayhet. Yeah. Nia. Yeah. Yeah, thank you. Tom. Yeah. Claire. Yeah. Simon. Yeah. Crystal. Yeah. Lachlan. Yeah. Sean. Yeah. Daniela. Yeah. Stuart. Yeah. Jason. Yeah. Scarlett. Yeah. Lillian. Yeah. Tess. Yeah. Jonathan. Yeah. Michelle. Yeah. And Roberto. Yes. Jason. Yeah. Angela. Yeah. Audrey. Yeah. Tom. Yeah. Anita. Yeah. Ryan. Yeah. Anthea. Yeah. Emily. Yeah. Leo. Yeah. Madeline. Yeah. Herbert. Yeah. Samuel. Yeah. Aaron. Yeah. Tony. Yeah. Sean. Yeah. John. Yeah. Sarah. Yeah. Basha. Yeah. Lucia. Yeah. Katie. Yeah. Jacqueline. Yeah. Lachlan. Yeah. Mia.
She's running late.
Rebecca. Yeah. Rude.
Yeah.
Maze. Louise.
Yeah.
Uchi.
Yeah.
Saad. Michaela.
Yeah.
Akel. Yeah. Jordan.
Yes.
Charlene.
Yeah.
Alexi. John.
Yeah.
Simon. Yeah. Wesley. Yeah. Jason. Yeah. Mizuki. Yeah. Corinne.
Yeah.
And Bryn.
Yeah.
Alright, today's lesson's very short, so that's good news for you guys. A lot of practice, but because I've taught you all the theory, most of the theory anyway, I haven't taught you to visualize yet for continuous probability in terms of how expected value and variance affects the graph. But at this point, you do understand what is expected value. That is your mean. Variance is a spread, and standard deviation tells you that exact value in terms of understanding how much of the spread is. Okay, and it talks about the error. Today, you're actually only doing calculation or interpretation of the mean, median, variance, standard deviation for continuous variables. Okay, so I showed you yesterday why you have to find the area to find the probability. So you established that the area under a curve is a probability, but it needed to satisfy two conditions. Now that function, if it does satisfy those two conditions, what is that called again? Can I please have Sean lean? What is that called? You got a function that satisfies two conditions for you to use in continuous probability. What is that called? What is that function called? Good, probability density function. That is a specific type of function, an f of x curve. It could be any curve, but it has to satisfy two conditions so that you could use for conditional probability. But what are those two conditions? John, name me one.
F of x is greater than
Yes, but what does that mean? Why does f of x have to be greater than or equal to 0, Ryan? Not sure. Why does a curve f of x have to be above the x-axis? Why? What's the logic, Danielle?
Probability can't be negative.
Yeah, probability can't be negative. I just said from yesterday's session that the integration, the area under the curve, represents probability. How would it make sense if you have a curve that is below the x-axis and you found the area, and that's a negative area? Because then that means that you got negative probability. That doesn't make sense logically. So therefore, to model a situation, the model continuous variable problem, f of x, which is the curve, has to be above the x-axis, which makes sense what John's saying. John's saying that it has to be, f of x has to be greater than or equal to 0, so above the x-axis. But then there's another condition. What's the second condition, Akel? Not sure, Mizuki. Not sure. We're thinking about probability and two conditions to make it a PDF function. What is it, Roberto?
You go from negative infinity to infinity is
Why?
Good. Why does the integral negative infinity to infinity have to equal to 1? Why do you have a curve and you found the integral, which is the area under the curve? Why does the area under the curve have to equal to 1? Bryn, what's the logic to this? Yeah, total probability has to add up to 1. That's what you've all known. That's a property that you learned back in year 7 when they had scales. They're like certain, uncertain. You had to go from 0 to 100%. You're either 0% sure or you're 100% sure. So you knew from year 7 that the probabilities can only range from 0 to 1. So it made sense that the area under the curve, which is your probability, had to add up to 1. So that's why those are the two conditions. If it meets that, if the curve meets that, we call that a probability density function. And that just means now you can do continuous probability. It just means now that if you have a continuous variable like height, weight, time, you can find the probability of this by finding the area under the curve because they're intervals. Okay, and that's what I was showing in yesterday's session. That's what I was trying to explain. Because once you understand that concept, today's session is just understanding where these rules come from and how to apply it. Because expected value is your mean. So you'll be finding out, what do you expect, if you had kids that were born at a certain weight per month, let's say we measured month by weight, and we wanted to find the probability of a child coming out in 3 months has a weight in terms of average is 4 kilos. Or 3 kilos. I don't know how much they normally weigh. Okay? What's the chance of that occurring? There is a way to calculate that. And that would be your conditional probability condition that has to be PDF. That's it. Simple as that. So, here we go. This is what you learned from chapter 13. Chapter 13 is from discrete probability. We knew to find the mean, which is the average, and I showed you where this formula came from. I showed you that the average is really just the sum of x, which is your variable, times the probability of variable occurring. Now, there's no difference to continuous. It's the same theory. The theory doesn't change. It's still the same thing. Average is still your x variable times the probability of that variable occurring. So, this is what we found out yesterday. We said that the probability of something occurring, or probability of that x variable occurring, was negative infinity to infinity of f of x. That is the probability. That tells you to find the area under the curve. So, and that sums all the possible probabilities that had to equal to 1. From negative infinity to infinity equals 1. So what that is really just saying already is that is a sum, and that's your probability. So how do you find the expected value? It might seem like it looks hard, but really it means the same thing. They're just saying x times integration of negative infinity to infinity of f of x. Sum of all x times the probability. Exactly the same thing. There's no difference between this formula. It is x times the probability. Sum of all that negative infinity to infinity, that gives you the probability. That's what you wanted. X times probability. That's where this formula is coming from. You can use the same logic to figure out your variance. Right now, if you understood variance, which I gave you the theory as x minus your mean all squared, then you can also use this understanding to find out the formula for conditional probability. Continuous probability. That's the same thing. If you know e of x, if e of x equals to integration negative infinity of x times the probability, in our case it would be f of x, that's your function. Whoops. Then how is it different? If this is x, and that's where x is, then e of x minus mu squared, the variance formula would naturally be exactly the same thing. It would just be x minus mu squared times f of x dx. And voila, there's your variance formula. That's the same thing. No difference to what you've been knowing. That's why I said if you understood chapter 13, the theory carries on. It carries on to binomial, it carries on to continuous, and then you can do normal. It's the same thing. Okay, the understanding of it is exactly the same as well. It's just that you have to use a different approach to getting the same answer. Okay, because of the variables. The variables change the situation. It changes the problem. That's it. So today, all I'm just teaching you is to memorize a couple of formulas or understand where it comes from. And the first one, which is this, how to find the expected value or the mean
when it's a continuous variable, random variable. These are the properties that you learnt from chapter 13, but just in case you forgot, I just stuck it in so that you don't forget. Okay? If you're confused by what this is here, this is just meaning the expected value of a function. How do you find that for continuous variable? Same thing. It'll be your function times f of x. If it was e of x, then you would have said integration of x times f of x. If it was e of x squared, then you would say it is integration of x squared times f of x. No difference. Exactly the same thing you've been doing for discrete. Chapter 13, you did that. Okay, exercise, chapter 13, the last few exercises talked about the mean. You had to do that. Same thing. No difference for continuous. What was the difference? We're now dealing with integration because it's the area. That's why you did that. Okay? So moving on, this is an example. It's an example from your textbook. You can look at your textbook for this, but it's the same thing. Find the expected value of the random variable x. In our case, we know this random variable x is continuous because they tell you it is a probability density function. That's the biggest hint, that you've got a continuous random variable. Okay, and we know that it meets the two conditions. It all adds up to 1. And we know that the graph is above the x-axis. That's what we know. Okay, now they're asking you to find the expected value. Have a go with this. Doodle it somewhere. Write out this working solution. You don't have to write out the actual answer if you don't want to work with integration of 0.5x. But I want you to write out the working solution. What would you do to find out the answer? Given that the formula e of x is equal to the integration x times the probability of f. And probability is the area under the curve. That's why it's integration of x times f of x. That's your formula. Let's figure it out for me. Given that you got this graph. So visualize the graph if you have to. Visualize the graph. It's just 0.5x, the linear equation. Half x. Linear equation from 0 to 2. Anything greater than or less than 0 and greater than 2 is 0. Picture the graph. What are you trying to find? We know that the total area equals to 1. I want you to find the expected value. Why is it 1 equals 1? You're trying to find the expected value. Alright, let's go through the answer. Listening. If you had to visualize this, 0 to 2, straight line equation, at 2, if I had x equals to 2, 2 times a half is 1. So I know height of 1. That's my triangle. And the rest, less than 0, if it's less than 0, I've got 0. So there's my graph. And greater than 2, there's my graph. Open circle, yeah? That's what I have so far. I said that it's a PDF function. Well, it is above the x-axis. That's true. The area has to equal to 1. Let's see if that's true. The area of a triangle, base 2, half base, which is half of 2, which is 1, times the height, which is 1. Yes, the area does equal to 1. So it is a PDF function. True. Okay? Now I've got this PDF function. I want to find the expected value. The expected value, we know it is your x variable times your function. My function is 0.5x because everywhere else is 0. So instead of it being from negative infinity to infinity, it is from 0 to 2. I want to know where is my expected value. Where do I expect to occur. So my expected value is now x times my function. What's my function? 0.5x. 0.5x times x gives me 0.5 x squared. 0.5 is a constant. You can take out 0.5. X times x is x squared. Integration of x squared. X cubed on 3. It's from 0 to 2. Work that out. That's just like half multiplied to 2 cubed, which is 8 on 3 minus 0. And that just gives you 2, and the 8 becomes 4 and 3. So what does that mean? What does the 4 and 3 mean? It just means the average. The long-term average you expect it to occur is right at, in terms of the graph that I drew before, if that was 2, then at 4 on 3, just a bit above 1, that's where I expect it to be, whatever that probability is. Okay? That's where my expected value is. That's where I expect it to be in the long term. Okay? Simple as that. And if you want to find the probability, how do you find the probability now? See, if I can't find the probability exactly at 4 and 3, but I can find the area up until that point. Okay? And that's all you're doing. And in this exercise, that's 15b. You're spending time to play around with the expected value. That's all you're doing. Just reiterating that same skill, x times f of x, x times f of x. And they might play around with it. They might give you e of x squared. How does that change things? It doesn't change much. All it does is, it's x squared now. So the problem would have been, instead of x squared, it would have been x cubed. That's the only difference there. And therefore, this would have been x to the power 4 on 4. That's the only difference. And you do need that. Why do you need e of x squared? Because that is the formula for your variance. Okay, to find out your variance. So you do need to understand that. Okay, let's go into variance now. This is the formula for variance. You can memorize it or just understand it. It's the same thing. If you knew e of x was x multiplied to your probability, and probability is the integration, there is no difference. Look, if that's x, that's x. If there's e of x minus mu squared, then it's x minus mu squared. No difference. Exactly the same thing. And still find the expected value. You just got whatever you're changing in the variable there. It could be a function, could be whatever it is. That's what you're doing. Okay? And that's your variance right there. So the only thing you had to understand was that. And that's what I spent in chapter 13 trying to explain what variance was. It was the residual, it was the error, the difference in error. If I predicted what you got and what your actual data is, you minus the difference to find out how bad my error is. Then you sum it all together. But the problem with that is you got negatives and you got positives. They'll cancel out to zero. That's why you square it, to avoid that. That's where variance came from. But then when you square it, then the error is now like squared. It's not exactly true in what I was predicting and how bad my error is. That's why the standard deviation is the square root of that. That's why standard deviation is equivalent to the square root of variance. That will actually tell me now how bad my real error is. That tells me the spread. How many people that I predicted got, I don't know, let's say 3 wrong or 4 wrong or 3% wrong. That's what it is. Okay, so that was a theory from chapter 13. We're just applying the same theory now into continuous variables. And it's just a different approach, it's integration. Okay? So, let's do a problem. Oh, you remember, this is the theory. That's how you do it. Anyone remember the computational formula? I gave you a computational formula. I said that this is a theoretical, but for variance, I told you, in order to work out the variance, there's a formula I wanted you to learn, because that's the one you use in the exam. What was it again? E of x squared. Good. Not equal to 0. There you go. That is your variance. That's the computational meaning. And I showed you where that formula came from as well. You don't need to know where it came from. You can just memorize that. That is the one that you would use to calculate. When I say computational, it means calculate. If you want to understand the theory, that's where the theory came from. Okay, but if you want to calculate it, use this. Why do you want to use this for integration or for continuous probability? Because this is the same thing as saying integration of x squared times f of x minus integration of x times f of x dx, sorry, I'm missing the dx, all squared. You can do that, okay? This one might be a bit trickier, that's all. But it works, either way works. I'm just telling you the computational formula, I want you to memorize that for discrete. You can use that for continuous as well, okay? All right, let's have a look. This is your problem. Same thing again, 0.5x. This time I want you to find the variance and standard deviation. Now in the previous one you found out the mean already. You know the expected value. There was 4 on 3 if you forgot. Okay, so we found out in the last example, e of x is 4 on 3. Now you can either use a computational formula to start solving, or you can use their formula from the from over here and try to solve. Okay, but regardless, I want you to find the variance and standard deviation for me. I'm going to give you 2 minutes. Okay, by hand. It's 0.5x, it's not hard. It's a fraction, half. And then once you got the gist of this, then I got one exam question I thought was pretty nice to do. Not many people did well on it, but it depends on how well you understood expected variables, properties of probability, and applying it to answer the question. Okay, so it's a VCAA question. I think it was a 2015 one. Can't remember. So 2 minutes to do this one.
No, he was giving it. It's got still chat with. He said one day. Because I want to learn. I have that personality that I want to. Can't believe you think that.
All right, let's go through the answers. Now, either way, it didn't matter which approach you did. You either use the first one or the second one. I would have recommended the second one because you already got e of x is 4 and 3. So really, this step here, that's just said 4 and 3 squared. So you got half of it done. All you had to figure out was what e of x squared is and then subtract it from each other, and that would have been easy. Okay? So, using this understanding, here we go. They're using the computational formula, just as I would have said. Same thing, e of x squared minus mu. That's just another symbol for saying e of x all squared, or your average or your expected value squared. Okay? We already got that as minus 4 on 3 squared, which is 16 on 9. We already know that one. What we need to know is what e of x squared is. And as I just said before, it doesn't matter what the inside is. If it's x squared, then the only difference is this is now x squared. That's the only difference. There you go. So you would have calculated, same thing, x squared times x, difference is x cubed. Integration becomes x on 4 on 4, x to the power 4 on 4. Sub 2 in, sub 0 in, 2 to the power of 4, 16. 16 and 4 is 4. 4 times half, which is 2. So therefore, that's e of x squared, computational formula. Computational formula, we know it's 2 minus then whatever 4 and 3 squared is. So, here we go. 2 minus 4 and 3 squared, which is 16 on 9. 2 minus 16 on 9. 2 on 9. That's your variance. How do you find your standard deviation again? Square root. Which, looking at that, I know it's root 2 on 3. Bam. That's not hard. And that's 15C. 15B, 15C, those are the formulas you need to understand. Cool? Alright. So what did I show you today? Expected value, how to find that. Expected value, variance, standard deviation. I linked it back to chapter 13. If you didn't understand that, go back to my videos and try to understand expected value, variance, where that idea and theory comes from. Because once you understand the theory, it applies to all chapters. 14, 15, 16, 17. Oh, actually not 17. Okay? Same thing, over and over. Right? Now, use that understanding. Now you have a theoretical understanding of things. Do the 2015, exam 2, question 9. Read the question. How do you know it's continuous? PDF again. It's probability density function. Biggest key that you're dealing with a continuous random variable. Answer the question. They said, if A is greater than 2, then the expected value is equal to what? So you've got a graph. You can see that this is 0, 0, that's my A. And if you knew that A is greater than 2, find out A for me. Have a go. Use all the properties you know. You know it's continuous. You know it's probability density function. I asked you before, I said, what does it mean when it's a probability density function? Use those two properties. Use your understanding of expected value. Put it all together. Problem solving. Put it all together and solve.
Also, we should be going on.
People who don't know what they're doing with their lives. Speaking of the time that in New Zealand,
Long, do you mind if we just have some people sticky beat?
No, I'm just about finished, but alright, sure.
Oh. No.
While they're coming in and lunch, this is when you guys sound like you're interested.
Sound like you care about mathematics, okay? This is where I would now say, okay, let's go through the answers. And we have our answer here. Hopefully we got B is the answer. Hands up if you got B. Fantastic. Oh, fantastic. Now those who didn't put up their hands, I'm going to fail you now, okay? We've got people to impress, okay? This is the answer, B. 37% in that year got B. So it was a hard question for most of them. Why? It's a very simple concept. If you understood it was from 2 to A, the area had to equal to 1. Probability density function had to equal to 1. That was the first step you had to understand PDF function. Area under that curve. Whoops. All right, now do what you want. No. Still. We had to know the area had to equal to 1. That was the first step. Integration of this function. This is a straight line. 160. Oh. That's the first step. You have to understand that as a PDF function. Shh. I'm still recording. So, listening. So you have to understand that curve is a straight line, and we knew it's 1/6. So it's just integration of 1/6. The area under the curve from 2 to A has to equal to 1. That's the first step. Okay, and then once you can then figure out the potential of what A must equal to, if you do that, you find that A equals to 8. Once you know A equals 8, that's when you can use your understanding of what expected value is. And I gave you the formula today to find out the expected value. You do that and it has to equal to 5. Okay? Oh, well, if you work it out. Here we go. So, A equals 8. And if you follow it, integration, you sub 8 in, you sub 2 in, it'll equal to 5. That's why you know the answer's B. Okay? Alright. Now, you got about 8 minutes. If you have questions, I'm going to come around and help. Otherwise, you may pack up and sit here because there are people around. Okay, so sound like you're doing something. Sit around.
Johnson didn't go up.
So when they say winning at least 2, they're just saying that should be now that is easier to say.
No, I'm not. I'm believing you.
There's 2 ways to do this. Or, if you ask me there, sketch that, and then draw the point line, and you know where the intersection is.
What do you want? It's all recorded. I shouldn't have said that. What do you want, Shirley? I'm willing to help you.
Hey, I actually watched the video, so it's gonna be funny to hear.
I'm gonna snip off at the start.